reaction. We see how the concentration of reactant will disturb the reaction. Okay. How concentration of reactant disturb the reaction? Reaction is 2H2O2 will produce 2H2O plus O2. The higher the concentration of H2O2 result in faster decomposition as more H2O2 molecules are available to react. If the concentration is reduced, the rate of reaction of oxygen gas O2 evaluation decreases. How we know the concentration of reactant? We need to calculate the number of mole to know which concentration of reactant is higher. Mole in chemistry a standard scientific unit for measuring larger quantities of very small entities such as atoms, molecules, or other specific particles. This is to experiment to know the concentration of reactant will disturb the rate of reaction. In experiment 1, volume of H2O2 is 5 cm cubed. The molarity of H2O2 is 0.1. In experiment 1, the volume of H2O2 is same with experiment 1, which is 5 cm cubed, but the molarity of H2O2 is 0.2. How we know the higher concentration of H2O2? We need to calculate the number of mole of H2O2. In experiment 1, we need to find the number of mole of H2O2. We can calculate the volume times the molarity to know the number of mole. We can know in experiment 1 the molarity is 0.1, then we get the number of mole is 0.5. Experiment 2 is 1.0 mole. So we can know the rate of reaction in experiment 1 is higher because the number of mole of reactant higher, the concentration of reactant higher.
Hi, I am Alicia. I will be presenting about carbon compound. So basically, carbon compound is a chemical substance which containing carbon. So for this topic, we're going to compare between alkane and alkene, which will produce more soot or will produce less soot. So for this chemical experiment, we're going to compare between alkane and alkene, which we're going to compare hexane from alkane group and hexane from alkene group to compare the sootiness of flame that produced during combustion. So the problem statement for this experiment is, do alkane and alkene burn with the same quantity of soot, or which will produce more or less soot? So the hypothesis of the experiment states that hexane burn with a more sooty flame compared to hexane. So we can state that alkene group will produce more soot compared to hexane. So we're going to undergo this experiment to prove that the hypothesis of the experiment is true. For normal human being, we can say that maybe some of the experiment we conduct may find something difficulties, or maybe something's error that we did during we did the procedure or undergo the experiment. So the result of the combustion do state that the combustion of alkane produce more soot and compared to alkene. But how can we prove the hypothesis if we conduct the experiment wrong? So we have another choice to prove the hypothesis is true by using the mathematical formula. We're going to find the molecular formula first. So as we can see from the previous slide, it doesn't state the molecular formula, but we can find the molecular formula for hexane and hexane. So we can apply our mathematical knowledge that we learn in basic geometry during school. So we can state that So hex shows name of polygon, which hexagon. So we know hex is 6 side. So we can apply that, switch 6 carbon compound in the molecule. Hexane formula, which C6H12 and hexane C6H14. So after we got both molecular formula for both molecule, we can compare the percent of carbon by mass per molecule by using the formula percentage of carbon by mass equal to mass over total mass of sample times 100. Substitute all of the value into the formula and we need to compare the percentage. So as we look at the percentage, we compare both, we can find that 85.71% is higher than 83.72%. Therefore, we can conclude that that is true hypothesis stated from the experiment, which hexane produced more soot than hexane. Thus, the hypothesis is accepted. This is because the percentage of carbon by mass per molecule is higher than alkane.
Okay, so now I will present about the thermochemistry. The example of thermochemistry is the combustion of methane. Consider the combustion of methane, which is CH4. So we need to calculate the enthalpy change, which is delta H of this reaction using the bond enthalpies. Step 1. We need to identify the bonds. In methane, there are 4 CH bonds. In oxygen, there are 2 O double bonds. In carbon dioxide, there are 2 CO double bonds, and in water, there are 2 OH bonds. Step 2, we need to look up the bond enthalpies. So here are the approximate bond enthalpies, which is the energy required to break the bond in kilojoule per mole. For CH bond is 412 kilojoule per mole. O double bond is 498 kilojoule per mole. CO bond is 799 kilojoule per mole, and OH bond is 463 kilojoule per mole. So step 3, we need to calculate the total energy of bonds broken. In methane, there are 4 CH bonds, so the energy to break them is 4 times 412 kilojoule per mole equals to 1648 kilojoule per mole. In oxygen, there are 2 O double bonds, so the energy to break them is 2 times 498 kilojoule per mole, which equal to 996 kilojoule per mole. The total energy required to break bonds is 1648 kilojoule per mole plus 996 kilojoule per mole, which is equal to 2644 kilojoule per mole. Step 4, we need to calculate the total energy of bonds formed. In carbon dioxide, there are 2 CO bonds, so the energy released when they form is 2 times 799 kilojoule per mole, which is equal to 1598 kilojoule per mole. In water, there are 2 OH bonds, so the energy released when they form is 2 times 463 kilojoule per mole, which will equal to 926 kilojoule per mole. So in this situation, the total energy released when bombs form is 1598 kilojoule per mole plus 926 kilojoule per mole, which is equal to 2524 kilojoule per mole. So the step 5, we need to calculate the enthalpy change, which is the delta H. For the delta H, the equation is energy of bonds broken minus energy of bonds formed. So it's 2644 kilojoule per mole minus 2524 kilojoule per mole, which will equal to 120 kilojoule per mole. From this example, we can get a conclusion that the enthalpy change for the combustion of methane is delta H equal to positive 120 kilojoule per mole. So since the result is positive, this means the reaction is endothermic, which is it will absorb energy.
Okay, next we are going to talk about application of mathematics in chemistry. So we are see the topic calculation of concentration of solution to manage wastewater. What the mathematical concept in calculation of the concentration? Concentration, which is C, mass of pollutant in milligram, volume of wastewater in liter. So these are the things from mathematics are used in the chemistry to calculate the concentration of a liquid. What are the applications? Industrial process often produce liquid waste containing chemicals, heavy metals, or other pollutants dissolved in water. So the chemist must calculate the concentration because the concentration of these contaminants in the wastewater influence the choice of treatment methods. So high concentration of pollutant might require more aggressive or specialized treatment technologies such as chemical precipitation, ion exchange, or membrane filtration. So we can see that mathematics is very important in chemistry, especially in the calculation of concentration to ensure the chemist can conclude which method are more suitable to calculate this. Okay, let's see an example. A factory release 15 milligram of lead (Pb) into 1,000 liters of water every day. Calculate the concentration of lead in the wastewater in symbol lah, milligram per liter. It is a unit. So these are the things we can see the mathematical concept in chemistry, which is the mass of the Pb, the volume of the wastewater, and also the unit that wastewater, the number of the concentration of the Pb in the wastewater. So we can conclude that mass of pollutant is 15 milligram, volume of wastewater is 1,000 liter. So we already see the formula, right? C equals to mass of pollutant over volume of wastewater. So we can do that 15 milligram over 1,000 liters. So we can conclude that the concentration of Pb in the wastewater is 0.015 milligram per liter. So after this, chemists can conclude whether which treatment can help to reduce the concentration of lead in the wastewater. So that's all. Thank you.
Okay, next, the application of mathematics in chemistry is we use in to find the base value and acidic. Okay, application of logarithm. The base formula use the logarithmic function to relate the concentration of hydrogen ion to the base value. Since hydrogen ion concentration are often very small, algorithm help to simplify the value into a more manageable scale. As you can you see, the formula is pH equals to negative log H plus. That H plus is the concentration of hydrogen ion in mole per liter. Okay, the example is if the concentration of hydrogen ion H plus equals to 1 times 10 to the power of negative 3, the base value is calculated as pH equals to negative log 1 with the power of negative 3 that equals to 3. If the concentration of hydrogen ion H plus equals to 1 to the power of negative 7, the pH value it is calculated as pH equals to negative log 1 10 to the power of negative 7 equals to 7. The logarithm relationship simplifies the process of understanding how the concentration of hydrogen ion affect the pH value. That's all for me. Thank you.